Hello dear viewers, welcome to another video tutorial of this YouTube channel. In today's tutorial, we're going to be focusing on question number 10, which is coming from the ECZ examination for school certificate, ordinary level, additional mathematics. So this question that we're going to be focusing on in today's tutorial, it is falling under the topic which is vectors. This question, it is the question which the internal candidates wrote in 2023. So let's try to check where the question is located in this paper, which the internal candidates wrote in 2023. So the question, it is question number 10, which is falling under the topic which is vectors. So let's try to check. It is question number 10, which is falling under vectors. So this is the question that we're going to be focusing on in today's tutorial. So it is question number 10. So this question, it is falling under vectors, just as we said earlier. This question has two parts. It has part A and part B. This question in total, it is carrying 9 marks. So this is the question that we're going to be considering in today's tutorial. It is question number 10, and this question has two parts. It has part A and part B. Part A carries 4 marks in total, and then part B carries 5 marks in total. And the entire question, it is carrying 9 marks in total. That's one thing. So let's try to go through each and every part of this question. We're going to start with the first part, which is part A. So part A states that the position vectors of P and Q relative to the origin O, for I plus 2j and ki plus 4j respectively, given that vector QP is perpendicular to vector OP. Find the value of k. And then we also have another part of this question, which is part B. Part B states that two lines R1 and R2 intersect at R1 passes through the points with position vectors 5i plus 3j and negative 2i minus 4j, given that R2 is equal to I minus 3j plus lambda open parenthesis I plus 2j close parenthesis. Find the coordinates of R. So this is the question that we're going to be considering in today's tutorial. This is the question that we're going to be considering. The next step that we're going to take is that we're going to get into the solving, but before we get into the solving, I would like to remind you that you should subscribe to this YouTube channel if you haven't yet done so, so that you can always be updated with the channel's new information. And as you subscribe, don't forget to turn on the notification button so that you're always going to be notified when there is any latest information on this channel. Don't forget to share so that others can also enjoy the tutorials of additional mathematics. Don't forget to comment so that we can hear out your views. And also, last but not the least, you can like this video by giving it a thumbs up. So now let's try to quickly get into the solving. So we're going to start with the first part of this question, which is part A. We're going to start with the first part. So we're going to identify the key terms that we have in this statement. So we have 2 points. That's one thing that you need to keep in mind. We have 2 points, P and Q, and we have been given the position vectors of those points. So we have the point P as 4i plus 2j, and also the point Q as ki plus 4j. That is what we have. So now one thing that you need to keep in mind is that these points are relative to the origin, or those are relative to the origin, and the origin is represented by the O. So in such a case, the points that we have, they are going to have the vector which is from O. That's one thing that you need to keep in mind. So it is relative to the origin O. That's one thing that you need to keep in mind. So it is running from O to point P and also from O to point Q. So we have the first vector which is from O to P. We have the vector OP, that is the first one. So we have the vector OP. So the vector OP, it is that one which is 4i plus 2j. That is the vector OP. And then what about the vector OQ? So even Q is relative to the origin, which is O. So it is going to be OQ. So OQ is equal to Ki plus 4j. So this is what we have. So we have these two vectors. We have vector OP and we also have vector OQ. This is what we have. And then what is the next thing that we're going to do? So it states that given that QP is perpendicular, so we have the term there we have the most important term which is there in this statement, which is perpendicular. So this term which is perpendicular, it is what is going to help us to find the value of k. So now what does it mean? So in vectors, when they mention this term which is perpendicular, it simply means that the dot product of two vectors is equal to 0. So when it comes to vectors, when vectors are perpendicular, the dot product is equal to 0. That's one thing that you need to keep in mind. So in such a case, they have mentioned that the vector QP and the vector OP, these two vectors are perpendicular to each other. So if these two vectors are perpendicular to each other, it means that the dot product is equal to 0. So vector QP and then times vector OP, when you consider the product of these, it should give you 0. That's one thing that you need to keep in mind, simply because they have mentioned that these are perpendicular. So now when you look at this, when you try to look at the vector QP, do we have the vector QP? We don't have the vector QP, meaning that we are supposed to find the vector QP. So now what are we going to do for us to find the vector QP? So we're going to say that vector QP is equal to, so the vector QP, it is going to be like, you're going to consider the first letter, and in such a case the first letter, it is Q. So it is going to be Q and then QO. This is how it is going to be. That is the first one. So you're going to consider the first letter, which is Q, and it is going to be at the first, which is going to be like Q, and then you're going to consider the O. You're going to write O, so it is going to be like QO. The overall is going to be like QO. And then another one, you're also going to say plus. You're going to consider the second letter, and it is going to be, it is not going to be at the beginning. The one which is going to be at the beginning this time around, it is O. So it is going to be O, and then P is going to be the second, and it is going to be like OP. So vector OP. So the overall is going to be like QP. The vector QP is equal to vector QO plus vector OP. So now let's try to go further. So vector QP, you're going to consider the first one, which is vector QO. Vector QO. So when you look at the first statement that we made the expression for vector OQ. We have the expression for vector OQ in the statement. That is what we have. We have the expression for vector OQ, and the expression, it is like Ki plus 4j. That is the expression for OQ. And then this time around, according to this expression that we have just made, it is QO. This is opposite. This is in the opposite direction. That's one thing that you need to keep in mind. At first it was OQ, but this time around it is QO, meaning that this is the reverse form. And if this is the reverse form, what does it mean? We're going to introduce the negative. If this is the negative form, if this is the reverse form, we're going to introduce the negative. So that is where the negative is coming from. And then the moment you introduce the negative, that's when you can consider the expression that you have there, which is Ki plus 4j. So now in this case, if you want, you can consider the expression just as it is, as Ki plus 4j. But in this case, in this tutorial, we're going to convert this into the column vector form, simply because I like working with vectors when they are in the column vector form. So if you want, you can also work with them when they are in this form, which is like Ki plus 4j. So we're going to convert this into the column vector form. Now, how do we convert this into the column vector form? So first thing, select get the term which is attached to the I. So the term which is attached to the I, it is going to be at the top, and in such a case, the term which is attached to the I, it is K. So K is going to be at the top. And then what about the term which is attached to the J? So the term which is attached to the J, it is going to be at the bottom. That's one thing that you need to keep in mind. So 4 is going to be at the bottom. So that is how it is going to be. So 4 is going to be at the bottom, and then you're going to consider the plus. The plus is going to be maintained like that. And then what about OP? In the statement, we have the expression for vector OP. So this time around, these two are just the same. In the first statement, we had vector op, and then even right now we have vector op. So we're going to get the expression just as it is. So that's one thing that you need to keep in mind. So this one, it is going in the same direction. We can say that this is the reverse form. This is why we have considered the addition, not the subtraction. So now what are we going to do? So we're going to get that the same expression for OP. So we have the expression for OP as 4i plus 2j. That's one thing that you need to keep in mind. So if you want, you can get the same expression, which is 4i plus 2j. But in such a case, just as I said, that we are working with these vectors in the column vector form, simply because I like working with vectors when they are in the column vector form. But maybe later I'm going to show you how the I and the j works if you use them. So now let's try to consider this expression. So the term which is attached to the I, it is going to be at the top, and then the term which is attached to the j, it is going to be at the bottom. So let's try to do further simplification. So that negative is simply applying to the term which is at the top and the term which is at the bottom. So in such a case, the term which is at the top, it is k, and the term which is at the bottom, it is 4. So now you're first going to consider the first one, which is negative times k, and it will give you negative k. And then when you say negative times 4, it is going to give you negative 4. So that is what we have. And then you're going to consider the plus, which is in the middle, like that. And then you're going to say 4 and 2 just as they are. So it is going to be like that. And then the next thing that we're going to do is that you're going to consider the expression. You're going to do the simplification and the calculations. So you're going to consider the terms which are at the top. You're going to consider the terms which are at the top. That is the first thing. So the terms which are at the top, it is negative k and positive 4, and between those two there is addition. So it is going to be like k, it is going to be like negative k plus 4. And then the next thing that you're going to do is that you're going to consider the terms which are at the bottom, and we have the terms as negative 4 and positive 2. So that is what we have there. So that is what we're going to do. So it is going to be the addition of negative 4 and positive 2. So it is going to be like negative 4 plus 2. And then you're going to enclose that in parentheses. And then the next thing that you're going to do is that you're going to do the simplification and the calculations. So it is going to be like vector qp is going to consider the top part. So when you consider the top part, these are not like terms. These are not like terms. That is what we have. These are not like terms, so we can't easily add them. So it is going to be like negative k plus 4. And then when you consider the terms which are at the bottom, you're going to say negative k plus 2. So negative 4 plus 2, it is going to give you the term or the value which is negative 2, simply because these two are like terms. So it is going to be like that. And then what you can simply do is that when you consider the top part, which is negative k plus 4, these terms can easily be swapped. They can easily be swapped so that maybe the expression can look nice. So in such a case, it is going to be like 4 minus k. So 4 minus k, it is just the same as negative k plus 4. And then this is how it is going to be. So at the top, it is going to be 4 minus k, and then at the bottom, it is going to be like negative 2. Okay, so now at this stage, we have now found the vector qp. So we have now found the vector qp. That is what our main interest was. Now what about vector op? Do we have it? Yes, we have the expression for vector op, so we don't need to worry about that. We're going to say we can now easily say that the dot product of qp and op is equal to 0, simply because we have all the expressions which are necessary. So that is vector op is simply equal to 4i plus 2j. That is what we have. So now let's try to replace the expressions that we have. So we have the dot product of the vector qp and the vector op. That is what we have. So now what is our vector qp? So vector qp, it is that expression which we found, which is 4 minus k at the top and then negative 2 down, which is in the column vector form. So this is what we have. So we're going to write that. So that is what we are simply going to write, and then we have the dot in the middle. So that dot is simply representing multiplication. That is one thing that you need to keep in mind. That dot, it is simply representing multiplication. And then what about O? So when you consider OP, what about OP? So now when you consider OP, so we have the vector which is having I and J. What are you supposed to do? In such a case, we are working with vectors which are in the column vector form. So we're going to convert this into the column vector form. But just as I said earlier, that if you like working with vectors in this form, which is like 4i plus 2j, you can work it out just as it is. But in this case, I said that I like working with vectors when they are in the column vector form. So we're also going to convert this into the column vector form. So when you convert this into the column vector form, it is going to be like we said that the term which is attached to the I, it is going to be at the top. In such a case, it is 4. 4 is attached to the I, and then the term which is attached to the J, it is going to be at the bottom. So it is going to be like that. So this is what we're going to have as OP, and that is equal to 0. So now we said that if we have the dot, it is simply talking about multiplication. That is one thing that you need to keep in mind. So in such a case, we're going to consider 4 minus k and 4. We're going to consider the top part. So we're going to consider 4, open parenthesis, 4 minus k. So that is what we have. Those are simply attached. So those are simply corresponding to each other. So they are going to be multiplied. And then we also have the bottom part. We have -2 and positive 2. So what we're going to do is that we're going to multiply. We're going to multiply these two. We're going to say that 2 open parenthesis -2, and then it is going to be like that. So we're going to do something like that. So when you consider 4 times 4, it is going to give you 16, and then 4 times -k, it is going to give you -4k. And then when you say 2 times -2, it is going to give you -4. So this is how it is going to be. So now at this stage away so now at this stage where you have reached, the next step that you have to note is that you're going to add the top part and the bottom part. So we're going to add the terms which are at the top and the terms which are at the bottom. That is one thing that you need to keep in mind. So we're going to consider the top part. In such a case, it is 16 minus 4k. That is the first one. It is going to be like that. It is going to be enclosed in parentheses, and then you're going to say plus the bottom term, and the bottom term, it is -4, so it is going to be enclosed in parentheses just as it is, and then that is equal to 0. So this is how it is going to be. And then what is the next thing? You're going to do the simplification. So you're going to say 16 minus 4k, and then you have plus open parenthesis -4 close parenthesis. So it is going to be like 16 minus 4k, and then when you consider positive times negative, it is going to give you negative. So it is going to be negative, and then 4, and then that is equal to 0. And then you're going to say 16 minus 4. 16 minus 4, it is going to give you the value which is 12. So in such a case, it is going to be like -4k plus 12 is equal to 0. And then what is the next stage after reaching this stage? So the next step that you are going to take is that you're going to say -4k. Remember, we're going to start the process of making k the subject, since our main objective is to find the value of k. So what we're going to do is that we're going to take positive 12 to the other side of the equation, and when it goes to the other side of the equation, it is going to be negative, and this is going to be -12. So the next step that you have to do is that you're going to divide both sides of the equation by -4. Since the main objective it is to make k the subject, so it is going to be like that. So k is equal to -12 divided by -4, which will give you the value which is 3. So this is how you easily score marks in the exam. So you can now say that therefore k is equal to 3. This is the value of k. This is how you easily find the value of k in the exam. I hope you have gotten the concepts. So this is how you easily answer part A. This is how you easily score marks in the exam. This is how you answer part A. K is equal to 3. So let's now go to another part of the question, which is part B. Part B wants us to find the point of intersection. That's one thing that you need to keep in mind. So we have two lines. We have two lines in part B. So we have two lines. We have one line which is labeled as R1 and then another line which is labeled as R2. So now these two lines, they intersect at one point, which is the point R. That's one thing that you need to keep in mind. So these lines are intersecting at a point which is R. One thing that you need to keep in mind is that it can be in a coordinate geometry or in vectors. When two lines intersect at a point, it means that when you say that R1 is equal to R2, you're easily going to find the coordinates of that point. That's one thing that you need to keep in mind. So it can be either in coordinate geometry or vectors. When you say that these equations are equal to each other, it means that you're going to find the coordinates of that point. So that is one thing that you need to keep in mind. So now when you look at this question, we're only given one equation, which is for R2, but we don't have the equation for R1. So now what are we supposed to do if we don't have the equation for R1? When you say R1 is equal to R2, that's when you're going to find the point of intersection, which is point R. So now let's try to consider R1. So if you want to find the vector equation of R1, you're going to consider this way. For you to find the vector equation, you're going to say that R is equal to A plus TB. That is one thing that you need to keep in mind. It is A plus TB. So now what does this represent? So A simply represents the initial position vector. That's one thing. So A is simply representing the initial position vector. So this is simply the starting point. This is the starting point. And then what about the t? T is simply representing the parameter. T, it is the parameter. And then what about b? B is simply representing the direction vector. T is representing the direction vector. That's one thing that you need to keep in mind. It is the direction vector. So now what is the next step? So in such a case, we're interested in the equation of R1. So now, how are we going to find the vector equation of R1? So the vector equation of R1 is going to easily be found simply because we have 2 points, we have 2 position vectors. So we're going to use those points to find the vector equation of R1. So that is what we are simply going to do. So we're going to write those position vectors that we have. We have 5i plus 3j and also another position vector as negative 2i minus 4j. So this is what we have. So now when you look at these position vectors, what we're simply going to do is that we're going to denote these position vectors with letters so that it is going to be easier for us so that we can know what we're solving. So we're going to denote these position vectors with letters. So we're going to denote the first position vector, which is 5i plus 3j as n, and another position vector, which is negative 2i minus 4j as. So now what we have here, we have the initial position vector. What is going to be our initial position vector? So the initial position vector, you can pick any among the position vectors that you have. In such a case, we have 2, so you're going to choose between these 2 position vectors. So you're supposed to choose the position vector which you are going to like, but you need to keep in mind that this initial position vector is going to affect your direction vector. That's one thing that you need to keep in mind. So you can pick A or B. So you can pick A or B, but in this tutorial, we're going to pick this one, which is 5i plus 3j. That is one thing that you need to keep in mind. So now what about B? So we have now found the initial position vector. What about B, which is the direction vector? How is it going to be found? So now if we say that our initial position vector, it is point M, it means that the direction is going to be from A to B. Since A it is the starting point, the initial position vector, it is simply the starting point. That's one thing that you need to keep in mind. So it is starting from A going to B. So that is how the direction is going to be. It is going to be vector AB. And then how are we going to find this? How are we going to find vector AB? So now for you to find vector AB, you are going to use the same concept which we used earlier, which is AB is equal to AO. So you're going to consider the first letter, which is A, and then you're going to put O, and then it is going to be like AO, and then plus, and then it is going to be, you're going to consider another one, which is B, and it is going to be OB, like that. So this is how it is going to be. So now let's try to look at the position vectors that we have. So we have the position vector which we denoted as point A. We denoted the first position vector as point A. That is one thing that you need to keep in mind. So this position vector, it is 5i plus 3j. That is one thing. So this point A, it is simply saying that it is vector OA. It is, we're going to assume that this is relative to the origin, which is O. This is how it is going to be. So it is going from O to A. So it is going to be 5i plus 3j. So this is the vector that we have. We have vector OA as 5i plus 3j. And then what about vector OB? So again, we're going to say that that point which is B, it is relative to the origin. So that point which is B, it is relative to the origin, and it is going to be OB. It is from O to point B. So it is going to be like negative 2i minus 4j, just as it is like that. So that is how it is going to be. And then what is the next step? So the next step that we're going to take is that we're going to start replacing what we have. So we have vector AB is equal to, do we have vector AO? That is the question. So in this expression that we have, which is in blue, it is AO. It is vector AO. But that expression which already has the expression which is 5i plus 3j, it is OA. This is in the reverse form. Earlier we're going to introduce the negative simply because this is in the reverse form. So we have AO in blue and we have OA in pink. So that is how it is going to be. So this is the reverse form. So it is going to be like, so the negative is going to be introduced like that. And then this time around, I'm going to show you how, when you consider this form, which is 5i plus 3j and negative 2i negative 4j works. I'm going to show you how this one works. So you're first going to introduce the negative, and then you're going to consider the expression which we have for OM. So you're going to consider the expression, and in such a case, it is 5i plus 3j, and then it is going to be enclosed in the parentheses, and then we're going to consider the plus which is in the middle. It is going to be like that. And then what about OB? So when you consider this one, which is OB, we already have it just as it is. We have the expression for OB, it is negative 2i minus 4j. This is how it is going to be. And then vector AB is going to be like that. So we're first going to consider the simplification and the calculations. So we're going to say negative times 5i, it is going to be, we're going to distribute the negative. So it is going to be negative times 5i, it is going to be negative 5i, and then negative times positive 3j, it is going to be negative 3j. And then the plus in the middle, it is going to be considered. So positive times negative 2i, it is going to be negative 2i, and then positive times negative 4j, it is going to be negative 4j. This is how it is going to be. So vector AB is equal to, so you're first going to consider the like terms. You're going to consider the like terms. So when you consider the like terms, it is going to be like negative 5i and negative 2i. These are like terms, so you can easily add or subtract. So in such a case, you're going to say negative 5i minus 2i, and it is going to give you negative 7i, and then when we have negative 3j and negative 4j. These are simply like terms. Again, we can easily add or subtract. So when you consider these, it is going to give you negative 7. It is going to give you negative 7j. So vector AB is equal to, so this is how this works if we were considering the I and the J. But again, we're going to switch to another form, which is the vector form, because I said that I like working with vectors when they're in the column vector form. So that negative 7 is going to be at the top simply because it is the one which is attached to the I. So it is going to be like negative 7. And then when you consider that one which is attached to the j, it is the one which is going to be at the bottom, and in such a case the term which is attached to the j, it is negative 7. So it is going to be like negative 7. So this is how it is going to be. So we now have the direction vector. We have now found the direction vector, meaning that the vector equation for r1 can easily be found. So in such a case, we're going to say that r is equal to a plus tb. So let's try to replace now. So r is equal to, the r is going to be like that. And then what about the a? We already found the initial position vector. We already found the initial position vector, which is 5i plus 3j. That is the initial position vector. So what we're going to do is that we're going to write it, and then if you want, you can select it just as it is like that, as I said earlier. But in such a case, we're going to convert this into the column vector form, and you're going to get the term which is attached to the I, it is going to be at the top, and then the term which is attached to the j, it is going to be at the bottom, and then it is going to be like that. So that is your position, your initial position vector, that is going to be your a, and then the plus is going to be maintained, and then the t is going to be written like that. So this t can be represented by the symbols such as the mu, the lambda, or the t, just as it is. So it is going to be like that. It is going to be written as the t in such a case. So it is going to be like t open parenthesis, and then what about the direction vector? We already found the direction vector, which is vector AB, and we're going to write what vector AB equals. In such a case, it is negative 7 at the top and then negative 7 at the bottom. It is going to be like that. So this is our R1. So we're going to write that, we're going to say that R1 is equal to 5 at the top and then 3 at the bottom, and then plus, and then t, and then we're going to write negative 7 at the top and then negative 7 at the bottom. It is going to be like that. So this is how you're supposed to find the vector equation. So now we have the two vectors, we have two vector equations, that one for r1 and that one for r2. So we can now easily find the intersection point. So now what is our R2? We already have R2 as I minus 3j plus lambda open parenthesis I plus 2j close parenthesis. So since we're working with these vectors in the column vector form, we are also going to convert this into the column vector form. So it is going to be like I, the term which is attached to the I, it is going to be at the top, and in such a case the term which is attached to I, it is 1. So 1 is going to be at the top. In such a case, and then we're also going to consider the term which is attached to j. So the term which is attached to j, it is negative 3. So negative 3, it is going to be at the top, at the bottom, and then we're going to consider the plus, and then lambda, and then we're going to say the term which is attached to the I again, it is 1. So 1 is going to be at the top, and then the term which is attached to the j, it is 2. So 2 is going to be at the bottom. It is going to be like that. So now we said that if we want to find the intersection point, and in such a case the intersection point, it is point R. So the intersection point, we're going to say that at that point R1 is equal to R2. So at that point R1 is equal to R2. That is one thing that you need to keep in mind. So we already have what R1 equals. So R1 equals to that is one thing. So we already found what R1 equals. It is equaling to that. So it is 5 at the top and then 3 down, and then we have t and then -7 at the top and then -7 at the bottom. And then what about R2? So we already found what R2 equals to, so it equals to that. So it is 1 at the top and then -3 at the bottom, and then we're going to have that, and then lambda, and then 1 at the top and then 2 at the bottom. It is going to be like that. So when you reach this stage, what are you supposed to do? When you reach this stage, what you're supposed to do is that you're going to consider the terms which are at the top. You're going to consider the terms which are at the top. That is one thing that you need to keep in mind. So out of this, we're going to make two equations. We're going to make two equations, and we're going to solve those two equations simultaneously. So let's try to proceed. So we're going to consider the top terms. So the terms which are at the top, that is what we're going to consider. So 5, we're first going to consider 5, and then plus, and then t. So t is going to be multiplied by -7 at the top, and it is going to be like that, and then is equal to, and then what about the one we're going to consider it, and then plus, and then lambda is also going to be multiplied by the top term. So it is going to be like that. So when you try to consider the simplification, t times -7, it is going to give you negative 7t, and then that is equal to 1 plus lambda times 1, it is going to be lambda. So that is what we're going to have. So this is the first equation that we have. This is equation number 1. This is the first equation. And then what about equation number 2? So we are also going to consider equation number 2. We are going to consider the terms which are at the bottom. That is one thing that you need to keep in mind. We're going to consider the terms which are at the bottom, and in such a case, those are the terms. So we're going to consider 3. It is going to be 3, and then we're going to consider the plus. And then what about the t? T is applying to both the top term and the bottom term. So in such a case, we're going to say t multiplied by the -7, which is at the bottom. So t times -7, and then we're going to consider the equal sign, and then we're going to consider -3, and then we're going to consider the addition, and then lambda times 2, it is going to be like that. So now we're going to consider the simplification and the calculations. So when you say t times -7, it is going to give you -7t, and then that is equal to -3 plus lambda times 2, it is going to give you 2 lambda. So this is how it is going to be. So this is equation number 2. This is equation number 2. So one thing that you need to keep in mind is that when you reach this stage, you can calculate the value of t or lambda. You can pick any which you want. You can pick t or you can pick lambda. So that is one thing that you need to keep in mind. You can pick t or you can pick lambda, but if you want, again, if you have sufficient time in the exam, you can solve for both t and lambda, but that is going to waste your time. Just pick one. You can pick t or lambda. That is one thing that you need to keep in mind. So that is what we have. But in this tutorial, we're going to pick this value, which is t. So if you have sufficient time in the exam, you can pick both. But in this case, if you don't have time, it is just going to waste your time. So you can pick both just for proving if you want. But in such a case, we're going to pick t. So we're going to consider the value of t. We're going to find the value of t. So the way that we're going to find the value of t is that we're going to first consider the first equation, which is equation number 1. We're going to consider the first equation. That is one thing that you need to keep in mind. So when we consider the first equation, we're going to make lambda the subject. We're going to make lambda the subject. How are we going to make lambda the subject? We're going to make one positive one go to the other side, and when it goes to the other side, it is going to be negative. So in such a case, it is going to be 5 minus 1, simply because those are like terms, and 5 minus 1, it is going to give you 4, positive 4. So in such a case, you're going to say lambda is equal to -70 plus 4. So this is what we have as lambda. So now, why were we finding the value of lambda? We're going to solve these two equations simultaneously. We're going to solve these two equations simultaneously so that we find the value which we want. We want to find the value of t, and the method that we're going to use, it is the substitution method. That's one thing that you need to keep in mind. We're going to use the substitution method. So we're going to use the substitution method for us to find the value of t. So that is one thing that you need to keep in mind. So when you solve these two equations simultaneously, that is when you're going to find the value of t. So this is one thing that you need to keep in mind. So after you consider equation number 1, let's try to consider equation number 2 now. So in equation number 2, we have the equation which is like 3 minus 7t is equal to negative 3 plus 2 lambda. So what we're simply going to do is that we're going to take negative 3 to the other side of the equation, and it is going to be positive 3. And when it becomes positive 3, it is going to be like 3 plus 3, simply because those are like terms. So 3 plus 3, it is going to be 6, and then negative 70, and then that is equal to, and then 2 lambda, that is equal to 2 lambda. So now what is the next stage? So one thing that you need to keep in mind again at this stage, it is going to be, you're going to replace wherever there is lambda with what lambda equals. So remember, in the first equation we already found what lambda equals. Lambda equals to negative 70 plus 40. So negative 70 plus 40, that is what lambda equals to. So it is going to be enclosed in parentheses like that. So you're going to consider the simplification and the evaluation. So 2 multiplied by negative 70, it is going to give you negative 14t, and then 2 times 4, it is going to give you 8, so it is going to be plus 8. So again, you're going to collect the like terms. So you're going to take negative 14t to the other side, and then 6 is going to go to another side. So when you take negative 14t to the other side, it is going to be positive, and in such a case it is going to be positive 14t minus 7t is equal to 8 minus 6 to the other side, simply because when you take 6 to the other side, it is going to be negative. So 14t minus 70, it is going to give you 70, and then 8 minus 6, it is going to give you 2. So remember, our main objective is to find the value of t. So the value of t, it is going to be 2 over 7. So you're going to divide both sides of the equation by 7. When you divide 7 divided by 7 on the left hand side, it is going to give you 1, and 1 times t, it is going to give you t. So t is going to be equal to 2 over 7. That's one thing. So t is equal to 2 over 7. That's how it is going to be. So now we have now found the value of t. So now, what is the next step when you find the value of t? So you're going to select the equation. You're going to select a vector equation which has t in it. So if you had found the value of lambda, you're going to select the vector equation for R2. But in such a case, we found the value of t, so we're going to select R1. That is one thing that you need to keep in mind. R1 is the one which has t in it. So that is the reason why we're going to select R1. So we're going to select R1. That is the one that we're going to select, simply because it is the one which has t in it. So we're simply going to replace wherever there is t with what we found. That is the reason why we had selected this one, and that is the reason why I was saying that finding both the values of lambda and t, it is going to be time consuming. But if you want, you can find both the value of t and lambda just for proving. So just to prove if you have found the correct coordinates. So in such a case, we're going to replace wherever there is t with what we found, which is 2 over 7. We're going to replace 2 over 7, and it is going to be like that. So the next thing, again, we're going to consider the simplification. You're going to consider this 5 is going to be at the top, and then 3 is going to be down. It is going to be like that, and then you're going to multiply. Remember that 2 over 7 is applying to both the negative 7 at the top and then and also the negative 7 which is at the bottom. So it is going to be like 2 over 7, and then 2 over 7 and then times negative 7 and then 2 over 7 again times negative 7. That is how it is going to be. So now let's try to do further simplification. So R1 is equal to, so when you consider 2 over 7 multiplied by negative 7, it is going to give you negative 2. And then again, when you consider 2 over 7 multiplied by negative 7, it is going to give you negative 2 again. So it is also going to give you negative 2. And then when you consider further simplification, you're going to first consider the terms which are at the top. You're going to consider the terms which are at the top. So when you consider that, it is going to be like 5 plus open parenthesis negative 2. And then again, when you consider the terms which are at the bottom, it is going to be like 3 plus open parenthesis negative 2 again close parenthesis. So it is going to be like that. So that is how it is going to be. So when you consider the top part, when you consider the top part, it is going to give you the value which is, when you consider the top part, positive times negative, it is going to be negative, and in such a case we're going to have 5 minus 2, and 5 minus 2, it is going to give you the value which is 3. So 3 is going to be at the top. We're going to have 3 at the top. And then when you consider the down part, when you consider the bottom part, we have positive times negative. Positive times negative, it is going to give you negative, and we're going to have 3 minus 2, and 3 minus 2, it is going to give you 1. So 3 minus 2, it is going to give you 1. So we have now found the position vector of that point. We have now found the position vector of that point, which is point R. So this is the position vector of point R. That is the actual point, which is point R. Or if you want, you can also write it in this form, which is 3i. So we said that the term which is at the top, it is simply representing the term which is attached to the I. So it is going to be like R1 is equal to 3i. Then again, we're going to say the term which is attached to the j, it is simply the one which is at the bottom, and the term which is attached to the j, it is 1, so it is going to be like j. So this is the position vector of that point. This is the position vector of that point, which is point R. It is R1 is equal to 3 at the top and then 1 down, and then we also have this one, which is R1 is equal to 3i plus j. So now one thing that you need to keep in mind is that when you consider the column vector form, the term which is at the top, it is representing the x coordinate, and then the term which is at the bottom, it is simply representing the y coordinate. That is how it is. And when you consider this vector form, which is 3i plus j, the term which is attached to the I, it is the one which is simply representing the x coordinate, and then the term which is attached to the j, it is the one which is simply representing the y coordinate. So in such a case, you can now say that the coordinates of R are 3, 1. These are the coordinates of R. We have 3, 1. These are the coordinates. So that one which we have, which is R1 is equal to 3i plus j, that is simply representing the position vector. But when it comes to the coordinates form, we're going to consider the coordinates just as we mentioned that when we consider the column vector form, the term which is at the top, it is the one which is simply representing the x coordinate, and then the term which is at the bottom, it is the one which is simply representing the y coordinate. So we have the x coordinate as 3 and the y coordinate as 1. So you can now say that therefore coordinates of R are 3, 1. This is what we have. So this is how you easily score marks in the exam. This is how you easily score marks in the exam. I hope you have gotten the concepts. So we have now come to the end of this tutorial. I hope you haven't forgotten to subscribe, to share, and to comment, and to also like. So don't forget to comment so that we can hear out your views. So we have now come to the end of this tutorial. This is how easy to score marks in the exam. This is how easy to score marks in the exam. Thank you for watching. See you to another video tutorial.